Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Nur Nafisa binti Azhar. I am from Group 70, AS120. So, for today's video presentation, I'll be presenting to you guys about a topic named manufactured substance in industry, which is alloy and glass. So, I hope you guys enjoy watching this video. Without further ado, let us begin with our topic. Manufactured substance in industry, alloy and glass. Pure metals such as iron rust easily when exposed to water and oxygen. Copper utensils are weak and soft due to their ductility and malleability. Thus, pure metal have limited uses. From the issue stated, we can see that a pure metal has such a lots of weakness. Okay, move on to the relationship among size and arrangement of atom in pure metals and its weakness. So, look at the left picture. The metal atoms are arranged orderly in layers. As you can see in the picture, the metals are arranged regularly because the size are the same, and also there is no empty space between them. Okay, and then some empty spaces exist in the structure of a pure metal. Okay, by looking at that picture, it's stated that there is elements that there is pure metal, but the arrangement of metal have originally empty spaces between the atoms. So, okay, look at the right picture. The layer of atom in a pure metal slides easily when force is applied. Okay, so the picture is the difference before and after a force is applied on the layer of atoms in a pure metal. Okay, as you can see in the left, before the force is applied, the arrangement of atoms are orderly in manner. But after a force is applied, the layer of atoms slides. So it means that the pure metal is ductile. Okay, and then next, metal atoms move easily to fill the empty spaces when force is applied. Okay, there is metal atoms that have empty spaces, right? As I said just now. Okay, so after a force is applied into the metal atoms move and fill the empty spaces. So it means that the structure of the atoms in the pure metal is not fixed because it can be changed after a force is applied. Thus, a pure metal is malleable. And then, the weaknesses of pure metals. The first one is pure metal is soft, and then ductile, malleable, and is low resistance to weight corrosion. Okay, next. So what is an alloy actually? An alloy is a mixture of two or more elements where the main element is metal. So, an alloy is produced when a different metal or non-metal atoms are mixed into a molten pure metal according to a specific composition. So basically, an alloy consists of a metal that is combined with other substance. It can be metals also or non-metal. So alloy is a composition which is a mixture of metal with other metals or a metal with other non-metal substance. So, the effect of foreign element with different atomic size in an alloy. The presence of atoms of different size disrupt the orderly arrangement of the metal atoms. Atoms in an alloy are not arranged orderly. So, by looking at that picture, it shows the difference between a pure metal and an alloy. As you can see, pure metals, the arrangement of atoms is orderly, but an alloy isn't, because alloy is a composition of metal with other substance. Thus, the size of atom is not the same. So, the arrangement is disrupted. Okay, next, move to the aim of alloying. So, the first aim is to increase the hardness and strength of a metal. Pure metal is ductile and malleable. Alloy is harder and stronger. As I said in the previous slide that a pure metal is ductile because the atoms slide easily when a force is applied. So by using the method of alloying, it can make the pure metals with the other substance become a compound that is harder and stronger. So for example, addition of little copper, magnesium and manganese to aluminium will produce duralumin alloy. So duralumin is harder than aluminium but still retains the low density of metal. And then the second aim is to improve the appearance. The surface of metal is easily tarnished because of the formation of metal oxide. If you guys remember in the first slide, I did mention about the rusting of iron, right? So, the rust layer is actually a metal oxide layer. So, when we use the method of alloying, it has a smooth and shiny surface, produce smooth and shiny surface. For example, addition of zinc to copper will produce brass alloy. Okay, brass alloy has a shiny and light golden color surface. So the appearance is improved. And then the third aim of alloying is to prevent corrosion. Metal atom is easily oxidized to form an oxidized layer, which is a rust. Oxide layers on iron and tin are porous. The strength of metal decreases. Addition of chromium into steel produces stainless steel, which is resistant to corrosion. So there is an example that stated that a stainless steel produced by addition of chromium and steel prevent the stainless steel from corrodes. So stainless steel has a shiny surface and corrosion resistance. So next, this is the composition of alloy. So I give you guys 5 examples of composition of alloy, which is bronze, brass, duralumin, stainless steel and cupronickel. Okay, to summarize, the properties of alloy stated here is harder and stronger than the original metals, and then most of them has a shiny surface and resistant to corrosion. So the first example is bronze, which is a trophy, brass, musical instrument, duralumin, a bullet train, stainless steel, a spoon and a fork, and cupronickel, a coin. So, move on to the next topic, which is glass. The main raw material used to make glass is fine white sand. Fine white sand is also known as silica sand because it is rich in silica compound or silica dioxide, SiO2. So this is the properties of glass, which is the first one is hard but brittle, chemically inert and resistant to corrosion, high compressive strength, electrical insulator, high melting point but high thermal expansion, poor heat conductor, transparent, and also recyclable and can be recycled easily. So, I'll be present to you a type of glass. There are 4 types of glass, and the first one is soda lime glass. The composition is silica, sodium carbonate, calcium carbonate, and other substance. The characteristic is, as you can see in the slide, lower melting point compared to other glass, easily molded into shapes and melted, has high thermal expansion coefficient. And the example are stated in the picture, which is bottle glass, bulb, and mirrors. And the second one is fused silica glass. It has only one composition, which is silica. Characteristic is, as you can see in the slide, and the example is spectacles, laboratory apparatus, and also telescope. The third one is borosilicate glass. The composition is silica, boron oxide, and sodium oxide. The example is laboratory apparatus, glassware dishes, and also car lamp. And the characteristic you guys can read in the slide. And the last one is lead crystal glass. The composition is silica, lead to oxide, and other substance. So the example is a prism, and then the glassware dishes also, as a plate and cups. So I think that's all from me. I will end my presentation here. So thank you.